Hello, this is Mr. Martin. In this video for geometry, we are continuing our review of radicals. And in the previous video, we finished with a quick review of how to do prime factorization using a factor tree. And in this video, we're going to look at how we can use those factor trees to help us simplify radicals. And the key here is without using your calculator. Okay? And then we're going to leave our answers. We're going to call this simplified radical form. So make sure you're following directions when you're working on problems so that you can get full credit for them. Alright, so let's take a look at square root of 18. So over here on the side, I'm going to start my factor tree. So I'm going to put 18 at the top. And then all I need to do is I need to figure out two numbers that when I multiply them I get 18. So I'm going to start with 3 times 6. Okay? Alright, so I'm going to go back here. I'm going to take a step back and I'm going to just rewrite my list of prime numbers so I can refer back to that. So I have 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Now this can go on again, but usually we won't have to go much higher. Usually we're going to stop around 7, 11, maybe 13. But most of the time we're looking for 2, 3, 5, 7. We're looking for those numbers. Okay, so 3 times 6. So I ask myself, do I have any prime numbers? Yes, this is a prime number, so I'm going to circle that, and I'm done with that branch. So now let's go back to the other branch. I need to break this down. So 6 is 2 times 3. Alright, so then I ask myself again, do I have any prime numbers? Yes, I do. 2 is prime, and 3 is also prime. Okay, so this is the prime factorization. So I know that 18 is equal to, and I'm just going to put this in order, 2 times 3 times 3. So let's come back over here to our problem. So the square root of 18 now is going to be the square root of 2 times 3 times 3. Alright? Now, this is where I'm going to do some rearranging. I'm always going to be looking for pairs of prime numbers under the square root. So here's a pair of prime numbers. So I'm going to take this pair and I'm going to give it its own square root. So this is a property of radicals that we can use. So it's going to be the square root of 3 times 3. And then I'll just put the square root of 2 back in its own radical. Alright? So now, since I paired that up, I have the square root of 9 and the square root of 2. Okay, and we know 9 is a perfect square. Let's write that down. Perfect square. Okay, and I know that the square root of 9 is 3. The square root of 9 is 3, and then the square root of 2 doesn't change, so then we're left with the square root of 2. So our final answer then becomes 3 square root 2. So if you do have a calculator and you want to plug in square root of 18 and see what you get, and then plug in 3 square root of 2 and see what you get, you'll notice that you get the same number. Alright, let's go ahead and try another one. Let's try part D. Alright, so I'm going to start on the side here with 56. Okay, and I need two numbers that when I multiply, I get 56. So I know that 56 is 7 times 8. Again, you could pick any two numbers that when you multiply them, you get 56. Okay, my question then is, are either of these prime numbers? If you need to refer back to your list, you have it up here. Oh, 7 is a prime number, so let's go ahead and circle that because that's the end of that branch. Alright, now let's break down 8. 8 is 4 times 2. Ask myself, do I have any prime numbers? Oh, 2 is prime, so let's circle that. That's the end of that branch. And then 4 is going to be 2 times 2. Alright, if you need to pause the video, if it's going too fast, feel free to pause it. And again, these are prime, so I'm going to circle them, so those are the ends of the branches. So now the square root of 56, I'm going to put these in order from smallest to largest, so it's the square root of 2 times 2 times 2 times 7. Right? 1, 2, 3 2's and 2 7's. And again, what I want to do is I want to look for pairs, because I can only take out pairs. So here's a pair of 2's, so I'm going to separate those out. So that's going to be the square root of 2 times 2. And anything that doesn't have a pair, I'm going to put that back under a radical, so altogether. Now, the square root of 2 times 2 is the square root of 4. And that's a perfect square, so we'll simplify that in the next step. And then any singles that are left, we can just multiply those back out. So that's going to be 14. And the square root of 4 is 2. And this is all the stuff that didn't have pairs, so that's 14. So we end up with 2 root 14. Alright, and again, if you want to check that on a calculator, you can. Alright, let's do one more here, and then you can do the rest on your own. So let's do f. So we have a negative 3 here. We're just going to take care of that at the end. So this is going to be negative 3 and then times whatever I get for 72. So let's do 72. So 72, I know, let's see, two factors are 8 and 9. So let's go back up here and see if 8 and 9 are prime numbers. 8 and 9 are not prime numbers, and we know that also because 2 times 4 is 8 and 3 times 3 is 9. So we're going to keep going. So 8 is 4 times 2. Alright, 2 is a prime number, so let's circle that. That's the end of that branch. And 4 is 2 times 2. So there's some more prime numbers. So let's go ahead and circle those so that we know that those are the ends of the branches. Let's go back to 9. 9 is 3 times 3. And those are prime numbers too, so let's circle those. Alright, so we have the ends of all of our branches. Let's go back and let's put everything under a single radical in prime factorization. So let's say I have 1, 2, 3 2's. And again, I like to put this in order. 1, 2, 3 2's. And 2 3's. And I'm going to highlight my pairs. So I have a pair of 2's and I have a pair of 3's. So those are going to get their own radicals. So let's just bring this negative 3 down for the ride. So it's negative 3. And then square root of 2 times 2. And square root of 3 times 3. Okay, I just took this pair of 2's and gave it its own radical, and that pair of 3's, and then I have a single 2 left over. Alright, so when you split it up, you should still have the same number of prime factors. Alright, now, this is going to be the square root of 4. So this is going to be negative 3, and then I'm going to skip a step here. I'm doing this in my head. The square root of 4 is 2, so 3 times 2. Make sure you do multiplication. And the next one, this is the square root of 9, and the square root of 9 is 3, so that's going to be times 3. Let's color code these two. So that's that, and then that's that, so we're just going down. That's going to be 2, that's going to be 3, and then we just bring down our square root of 2. And again, anything inside can get multiplied, anything outside can get multiplied. So I have negative 3 times 2 times negative 3, that's negative 6 times 3 is negative 18. And then we have this lone square root of 2 left over, and there is our answer. Alright, so I'm going to end this video here. Your assignment is to go back and finish the other ones that we didn't, so make sure you get help when you need it. And we will see you in the next video.